Okay, so as I guess my screen is visible to everyone, and these were the experiments that we are supposed to conduct in Tripoli 282, and we have completed the first five, right? So we have completed interpolation and regression, the curve fitting techniques. Then we have gone through solving simultaneous linear equation. I mean, if we have been given a set of equation, we can solve them to find out x, y, z, or the unknowns. And then in the previous session, we have gone through numerical differentiation and integration. Right? We uh, know the techniques how we can differentiate or integrate if we have been given a data table. Right? We can calculate the integral or derivative at a certain point. And today we will discuss about solution of nonlinear equation. So nonlinear equation means we have to find the roots of the equation. Okay, the roots of the equation. Okay, let me open a new script. So today's topic is actually so it should be visible now. Okay, so solution of nonlinear equation. Okay, we are uh, referring it as non-linear equation because the power would be greater than 1, or it might, the power might be 1 as well, but generally we have multiple roots. So the equation should look like this, like we will have this type of thing. Let's assume we will have 5x cubed minus 6x squared plus twice x minus 9 equals 0, and we have to find all the roots. Okay, so this is a non-linear equation actually, because as you can see, the maximum power is 3, right? So we have to find all the roots. As it is a cubic equation, we will have 3 roots. So our target is to find those 3 roots. Okay? This is the experiment today. Also, our equation might have this type of format, like it can have some exponential part, like 9 e power x minus 2 e power minus 5x equals to 0. Some exponential equation. Okay, from this equation we will try to solve the x as well, or we may have some trigonometric equation, like we may have 5 sine x minus 2 cos 2x. Let's assume we have some trigonometric ratio. Also we will have some exponential term like e power minus x, also some polynomial term like 6x equals to 0. So our task is to find the value of x for these equations. We have to find the roots. And what is the motivation to solve any equation using numerical techniques? The motivation is sort of the previous one that I discussed about. Let's assume we have been given this equation. So if we try to solve this analytically, then it would be, I guess, a bit tough, right? যদি আমরা খাতা কলমে এই ইকুয়েশনটা সলভ করা ট্রাই করি, তাহলে এটা একটু কঠিন হয়ে যাবে না? By the word analytical I mean that the way we generally solve in using our pen and paper, right? আমরা খাতা কলমে যেভাবে সলভ করি ওটাকে analytical বলতে যাচ্ছি. So if this equation has been given and we have been asked to find the value of the x, then the analytical approach might become difficult. So in these cases numerical approach can be helpful. Okay, so we will define some techniques, or not actually define, we will know about some numerical techniques that will help us to solve any nonlinear equation to determine the value of x, or the roots, actually the roots of the equation. ঠিক আছে, আমরা ইকুয়েশনের রুট গুলো খুঁজে বার করব নিউমেরিক্যাল টেকনিক দিয়ে, যাতে করে সহজে আমরা বের করতে পারি। এগুলো খাতা কলমে সলভ করা তো একটু কঠিন, তাই না? তো আমরা দেখবো যে আমরা কিভাবে নিউমেরিক্যাল টেকনিক দিয়ে সহজে এগুলোকে বের করতে পারি। ওকে, so we will this is a basic thing about solving nonlinear equation using numerical technique. Okay, so uh, we will first discuss about bisection method. The first technique that we are going to discuss is bisection method. So let's move. We will actually talk about three methods. Hopefully, the first one is the bisection. Second one is called the false position, and the third one is the Newton-Raphson. Okay. I guess some of you, I guess all of you might be familiar with Newton-Raphson method, because I guess in case of HSC level or hopefully in the A levels, you might have known about Newton-Raphson method for determining roots of equation. নিউটন-র্যাফসন মেথডের কথা আপনারা শুনছিলেন না? মনে আছে নাকি না? এরকম কিছু মনে পড়ে না? ম্যাথল্যাবের এক্সপেরিমেন্টে ছিল আই গেস আপনাদের এইচএসসি তে। ছিল নাকি ছিল না? আচ্ছা, ওকে, সমস্যা নেই। আমরা দেখব নিউটন-র্যাফসনও দেখব। না মনে পড়লেও সমস্যা নেই। So the first technique that we are going to discuss, so I guess you all understand what we are going to do today. What's our target? I guess it's clear now, and now we will see how we can do that. So the first technique is the bisection method. And for bisection method, we will not provide the code. Rather, you will have to write the code for yourself. Okay. I will discuss about the underlying theory or the approach how we can solve using bisection method, and also in the lab sheet you will be provided an algorithm, okay? But the code will not be provided. You have to write the code yourself. Okay, so the bisection method. As the name suggests, bisection, right? So we are going to divide by two. Simple words. Pi means two, section means two sections, right? So what we are going to do is that we will repeatedly divide our interval by two. Okay, so let's assume a scenario first, then we will move on to the details. Let's assume we have been given some function that look like this. So let's assume this is our y equals fx, and let's assume this is our x-axis and the y-axis, and we have a function that looks like this. Let's assume this type of function. Okay. So first of all, what do we understand by the word root or solution? X-axis. Okay. So what do we understand by roots of equation or solution? For yes, exactly. Can you please repeat once again? I didn't get you.
So is it like the turning point or the maxims and minims? It's like a polynomial.
Okay, so not exactly the turning point, rather we will focus on the intersecting point with the x. Okay, so if this is our function, this is our f of x graph, so this is y equals f of x graph. So if this is the function, to determine root, what we do, we actually equate it with 0, right? Like we have a function that looks like this: 5x squared minus 6x plus 2 equals 0. From there we want to find the value of x, right? So we have two roots here, we are willing to determine the two x's here. So what these x values actually correspond with the graph. So if this is the graph for f of x, then the points at which our graph intersect with the x-axis is the roots. So here if we look carefully, then it would be our one root, তাই না? আমাদের গ্রাফটা যেখানে এক্স অ্যাক্সিসের সাথে ইন্টারসেক্ট করে সেগুলোই হচ্ছে আমাদের রুট। হ্যাঁ, the graph, the point at which the graph intersects with the x-axis. Okay, so it would be our one root. It would be our one root. This value of x will give us one root for this function, this f of x, or the polynomial or exponential, whatever equation we have. So how we are going to determine this x coordinate, this x value? Our task is to find this x value using bisection method. So how we are going to do that? So let's assume In case of bisection method, as the name suggests, that we have to bisect, or we have to divide the interval by 2. Okay, so for bisection method we will have a given interval. Okay, so let's assume we have been a given interval from this to this. So let's assume this is the x low. We have to find the root in this interval. A polynomial or a exponential function might have uh, more than one roots. So in this case, we will be given an interval, and we will try to find the root in that interval. So we have been given this interval x low and x high, let's assume, and we have to find the value of x, the given root that lies in this interval. Okay, so x will lie in this interval. For bisection method, we are going to make this assumption that we will find the root within this interval. Okay, so let's extend the graph a bit more. Let's assume this graph. Okay, so what we will do, our task is to find these x value, and it is in between these given intervals, x low and y low. This is the x low value, and this is the x high value. Okay, so our first step, the method is the bisection method. So what we are going to do, we will divide the interval by 2 each of the time. So first we will make a check that the function value at x low and the function value at x high, we will check the function values first. This is our first task, that we will check the function value at x low and the function value at x high. So this is the y value or the function value, and this is the other function value. So this is f of x high, and this is f of x low, right? So before determining any root, we will check the two function values, whether they are of opposite sign or not. So this is one and this is another. So here we can see f of x high is of positive value, right? F of x high, the y value is positive here, and the y value is negative here. So whenever we have this type of scenario, then we can safely assume that one root exists in between these intervals. Okay, so whenever we have something like this, that f of x high, this is greater than 0, or f of x low, this is less than 0, or positive negative, if we say as it is positive, have a positive value, this y value is positive and this y value is negative. So whenever this situation arises, this type of situation arises, we can safely assume that a root lies in between this interval. The logic, based on the logic that as f of x low has a negative value and f of x high has a positive value, so there must be some point in between where f of x is 0, right? F of x 0 actually corresponds to the root. Yes, any query? Attendance. So যেটা আমি বলতে চাচ্ছিলাম যে f of x high, so the logic that I'm trying to say, as f of x low has a negative value and f of x high has a positive value, so there must be some point in between this interval where f of x is equals to 0, because the sign is changing as it is positive and as it is negative. So in this interval there is some point where f of x is 0, and that f of x 0 actually corresponds to the root, right? So we should have this type of situation, or we may have the alternate combination, like we may have the function value at x high, it could be a negative value, or the function of x low, it could be a positive value. We may have this type of situation as well. So in this case also a root lies in between. But if both of the values are positive, like f of x high and f of x low, both of them are positive. Let's assume this scenario. Uh, let's assume we have been given x low, or the interval in this range, this blue colored one. Let's assume this is our x low and this is our x high. So is there any root in this interval? Any root exists? No, exactly. So if you look carefully, then you can see for this blue colored x low, the function value is positive, right? The function value is positive. And also for x high, the function value is positive as well. So here we can see for these interval, for these x low and x high, both of the function values are positive. So if both of the function values are positive, then we will assume that no roots exist in between these interval. Okay. And similarly, so I guess, so the thing that I'm trying to say, if we have this type of scenario, like f of x high, this is positive, and f of x low, this is positive as well, then we will assume no roots in the given interval. Okay. And the same case is applicable if both of the function values are negative, like f of x high, this is negative, and f of x low, this is negative as well. So if this type of scenario occurs, then we will assume that no roots exist in the interval. So both of the negative value means, let's assume we have this type of thing. I'm going to delete this one. Let's assume our interval is given like this. We have been given this point and this point. I'm erasing these portions. Let's assume our given interval is now here. This is the x high and this is the x low. So for both of these points, we can see that this is a negative value and this is also a negative value. Right? So this is our x high, or this is f of x high if I want to say, and this is f of x low, the given interval. Okay, so if this type of scenario occurs, then we will safely assume that no roots exist in the interval. So only the case where we can find the root is where we have the alternate of the, we have an alternation of the sign of the function value. Okay, so let's extend the graph once again. So we will get function value for this type of scenario only. So this is our x low, and this y value is our f of x low. Okay. So one function value is positive and the other is negative. So whenever this type of situation arises, we can solve the value of x using bisection method. Okay, so that's the first step or the check before moving on to determining the solution. Okay, so this is a check. We should do this check and then move on to solving the root. So now we will try to find this root, the value of this x, our focus point. Okay, so I'm going to copy this graph and move on to next one. The algorithm will be given in the lab sheet, so I guess you will be it will be easier for you to understand. So now I will discuss how we can solve the x value. So what we are going to do, we will divide this interval at every iteration of a loop. Okay, so let's assume this is our given x low, this is our given x high. We will determine its midpoint. We will determine the midpoint of x low and x high. Let's assume, so as this is the midpoint, so x mid will have this equation: x high plus x low divided by 2, right? This x high, this x high, and this x low, and it will be divided by 2. We will equate, we will calculate the midpoint. And as we are actually dividing the interval equally in two parts, we are calling this method the bisection method. Okay, so the midpoint will be, I guess, here somewhere, like right, as this is x low and this is x high. Okay, let's zoom into the graph. So this is our graph and our target is to reach here. Our target is to reach here. How we can find this value? So I will give an overview how actually we are going to calculate this, then we will discuss more about the code. So the first step is to determine the midpoint. So let's assume as this is x low and this is x high, the midpoint would be somewhere here, right? So this is our x mid, the midpoint. And what we will do, we will see whether the function value is positive or negative for the midpoint. So we can see for this x mid, the function value is positive, right? The function value is positive. So what we are going to do, as the function value was positive for x high and for x mid the function value is positive as well, we will forget these x high and we will define this x mid as our new x high. Okay, let me repeat. First, we will determine the midpoint, and determining midpoint is pretty easy. That we will add x low and x high and divide it by 2. So we will get this x midpoint. This is the first step. We will determine x mid, the midpoint, and then we will calculate the function value at this x midpoint. So if we look carefully for this x midpoint, the function value is positive, right? So we will check uh, for which x low or x high the function value was positive, and we can see for x high the function value was positive previously. Okay, so what we will do, we will forget this x high. So I'm going to delete this. We will forget this x high and we will define this x mid as our new x high. So it would be our new x high. And we will do this thing over and over again. We will repeat this thing and we will reach to the solution in after some of the iterations. Okay, so let's do one more iteration. So we will do the same thing again. Here is our x low and here is the new x high, right? This is the x low and this is the new x high. We will calculate their midpoint once again. So let's assume their midpoint would be some place here. Let's make it here. So this would be our new x mid. So this is the new x mid, and after calculating the midpoint, we will check its function value, the function value for new x mid. So if we want to determine the function value here, so we can see the function value is negative. So we will compare for whether for x high the function value was negative or for x low the function value was negative. So we can see for x low the function value was negative, right? For x low the function value was negative. So we will forget the x low now. Okay, so we will forget the x low now. I'm going to remove this x low. We are going to forget this thing and update this x mid as our new x low. So it would be our new x low. Okay. So we have, so now if you can see from the given interval, we are closing to the root, right? As we will do this thing in iteration, we are actually approaching to our root, our target. Our target was here. We are becoming closer and closer for each of the iteration. So let's do one more iteration. Let's do it in blue. So now we will calculate the midpoint once again, and the midpoint will lie something in between, right? So this is our new x mid, this blue colored one. We have calculated the x mid by dividing the x low and xi by 2. Okay? Bisection. This is actually called the bisection. We are uh, actually sectioning into two equal parts. So the first step is calculate the x mid, then we have to check the function value here, and we can see the function value is positive. So we will forget these xi because for xi the function value was positive previously. So we will forget this one, and we will define this x mid as our new xi. This is the new xi. And one more time we are going to calculate the midpoint, and I guess you can see if we calculate the midpoint now, it will be pretty much close to our root, right? If we calculate the midpoint, then this green colored coordinate would be our x mid, and it would be pretty much close to our solution or root, right? So we will actually, we are determining the root as this x mid. I guess the approach is understandable to you, right? টেকনিকটা কি বোঝা গেল? আমরা কিভাবে রুটটা খুঁজে বার করতেছি আসলে বাইসেকশন করে, এটা কি বোঝা গেল নাকি? Okay. Okay, thank you. So this is actually the way how we are going to find any root using bisection method. We are actually doing a pretty simple task. We are actually bisecting the interval or equally dividing the interval and checking the function value and updating the x high or x low for each iteration, and after some iteration we will reach to the solution. Okay, so if it is understandable, then we will talk more about the code. Okay, so I've zoomed out. So our first, so if we go for the first point, our x low was actually something here. X low was somewhere here, the first in the first position, and the x high was somewhere here, right? For the first case, the given interval. Okay, so now I will talk about The algorithm is also given in the lab sheet. You have to write this code for yourself. Okay, the code will not be provided, and I guess you might have to do some modification as well after writing the code for bisection. The code is pretty much simple. So one more thing I should also talk about, that we should have some tolerance value. Okay, we should have some tolerance value. So what do we mean by tolerance value? If you can recall, we talked about tolerance value in the previous session as well, for numerical differentiation, right? uh, no, numerical differentiation, numerical integration. We discussed about uh, tolerance value. So here we should have the tolerance value once again, that how close we will go for the root, that would be our tolerance. Okay, how close we will approach to the root. Actually, if I zoom in, we may not be to the actual root sometime, but we may be very close to it. Okay, in some cases may not be actually to the we may not actually reach to the exact value of the root, but we will reach to a very close value. So that's why we are actually setting a tolerance. Tolerance means how close we are willing to reach to the root. Okay, so what we are going to do, that we will calculate the x mid, and then we will calculate its y value, the f of x mid, and then we will check whether this function value is positive or negative. Okay, so if uh, let's assume this is f of low, f of x low uh, is positive, and this f of x mid is positive as well, then we will update this x low as the x mid, right? Or we can check the other case, like we will have the same sign, right? So we will have this case as well, like if f of x low is negative and f of x mid is negative as well, then we will also update the x low value. Okay, if the function value matches, if the two function value matches, if both of them are positive, then we will update the x low, or if both of them are negative, then in that case we will also update the x low. And the case will also be similar for x high, f of x high. Let's assume if we have this type of thing, f of x high, this is greater than 0, and f of x mid, after calculating x mid, we have calculated the x mid, and then we have calculated f of x mid. This part we should calculate for each of the iterations, and then we will do these checks. Okay, we will do this check. So f of x mid is also greater than 0, we will update the x high as the x mid value, and also f of x high is less than 0, and f of x mid is also less than 0, then we will also update as f of x mid. Okay, so this is actually double ampersand. We are actually doing some conditional check whether they're true or not. So that's actually the iteration or the checks where we will calculate this type of thing, and then we will talk about the tolerance, right? So uh, if this x mid is pretty close to the previous value, we will calculate the difference between the two x mids, the previous x mid and the new x mid. Okay, and we will calculate the tolerance value, and we can check the tolerance value like this. If our x high minus x low divided by 2, this value is less than the set tolerance value, we will set the tolerance to a very small value, like we can set the tolerance to 10 to the power minus 6 or a pretty small value. It would be best if we can set it to 0, but setting it to 0 would increase the number of iterations to a very large number. Okay, so we are not going to actually set the tolerance to 0, but we will set it to a very low value. Okay, so if this condition is fulfilled, I mean, if we can check that this condition is fulfilled, we can say our solution is so what does it actually represent? X high minus x low. X high minus x low actually represents how close we are to the root. This is x high and this is x low. So if we divide these x high and x low, subtract them, then we will get this portion, right? We will get this portion. If we subtract x low from x high, we will get this portion, and if we divide it by 2, then we are actually getting close to this midpoint, right? We are actually getting close to this midpoint. So if we are very close to these, or this is a very small number, then we can safely assume that we can accept our solution. We can break the loop. Okay, so if this is a very small number, this difference is a very small number. This difference will be a very small number when we are close to the root. Okay, this difference will be a very small number when we are close to the root. So whenever this is less than the tolerance value, then we can say our solution is that x mid. Okay, and then we can break from our iterations, or we can break from our loops and output this value as our solution of the root. Okay, আচ্ছা আমি একটু বলি, বাংলায় বলি কি বলছি, হয়তো ইংলিশে অত ভালো বোঝা হচ্ছে না, আমি একটু বাংলায় একবার পুরোটা এক্সপ্লেন করি। হ্যাঁ, তো ফার্স্ট অফ অল যেটা আমরা করলাম, আমরা তো ওই মিড পয়েন্ট গুলো ক্যালকুলেট করলাম। ওকে, লেট মি এক্সপ্লেন ওয়ান্স এগেইন, and if you have any query, please feel free to share, because you have to write this code yourself. ঠিক আছে, এই কোডটা কিন্তু আপনাদেরকে লিখতে হবে, কাজেই বুঝতে অসুবিধা হলে আমাকে প্রশ্ন করতে হবে। হ্যাঁ, আচ্ছা, তো তাহলে আমরা যেটা করতেছিলাম, আমরা ফার্স্ট অফ অল আমাদের যে গিভেন এক্স লো ছিল, এই পয়েন্টটা গিভেন এক্স লো আর যে গিভেন এক্স হাই, এই দুইটাকে 2 দিয়ে ভাগ করে আমরা এক্স মিডটা ক্যালকুলেট করতেছিলাম কনস্ট্যান্টলি, মানে কন্টিনিউয়াসলি, সরি। তো এক্স মিড ক্যালকুলেট করে তার ফাংশন ভ্যালু ক্যালকুলেট করতেছিলাম। এরপর আমরা চেক করতেছিলাম এই যে ফাংশন ভ্যালুটা আমরা পেলাম, এই ফাংশন ভ্যালুটা কার সাথে মিলে। হ্যাঁ, যদি এফ অফ এক্স লো এটা গ্রেটার দেন 0 হয় আর এফ অফ এক্স মিডও গ্রেটার দেন 0 হয়, তার মানে দুইজনই পজিটিভ। তো দুইজন পজিটিভ হলে আমরা এক্স লোটাকে আপডেট করে দিচ্ছিলাম এক্স মিডের পয়েন্টটা দিয়ে, তাই না? যেটা ওই যে আমরা করে করে দেখলাম। তো বা যদি দুইজনই নেগেটিভ হয়, দুইজনই যদি নেগেটিভ হয়, তখন আমরা এক্স লোটাকে এক্স মিড দিয়ে আপডেট করে দিলাম। সিমিলারলি এক্স হাইয়ের ক্ষেত্রেও তো সেম ঘটনা, তাই না? আমরা এক্স হাইটাকেও তো আপডেট করা লাগতে পারে, যে এই যে এক্স হাই আর এক্স মিড এরা দুইজনই যদি পজিটিভ হয়, তার মানে সেম দিকে পড়ছে আমাদের, তাই না? আমাদের এক্স মিডটা এক্স হাইয়ের সাইডে পড়ছে, এক্স মিডটা এক্স হাইয়ের সাইডে পড়ছে, কাজেই এক্স হাইকে আমরা তখন আর কি আপডেট করে দিব এক্স মিডের পয়েন্টটা দিয়ে। অথবা যদি এরকম কেস হয়, এক্স হাইয়ের ভ্যালু হলো এক্স মিডের ভ্যালু হলো, এরকম কেস যদি হয়, তখন আমরা এক্স হাইকে এক্স মিড দিয়ে রিপ্লেস করে দিব। তো এখন এই কাজটা আমরা কতক্ষণ করতে থাকবো, এই ইটারেশনটা আমরা কতক্ষণ করতে থাকবো? কতক্ষণ করতে থাকবো? যতক্ষণ পর্যন্ত না আমরা আমাদের রুটের খুব কাছাকাছি পৌঁছে যাই। হ্যাঁ, এই ইটারেশনটা আমরা করতে থাকবো ততক্ষণ পর্যন্ত, যতক্ষণ পর্যন্ত না আমরা আমাদের রুটের খুব কাছাকাছি পৌঁছে যাই। তো রুটের কাছাকাছি পৌঁছে যাচ্ছি, এইটা বুঝবো কিভাবে? তো এইটা বোঝার উপায় হচ্ছে আমরা যে এই ডিফারেন্সটা নিব। আমরা তো কনস্ট্যান্টলি এই দুইটা পয়েন্ট কাছাকাছি চলে আসতেছে। আমাদের এক্স হাই আর এক্স লো প্রথমে অনেক দূরে ছিল, একজন ছিল এইখানে আর আরেকজন ছিল হচ্ছে এইখানে, তাই না? দুইজন আগে দূরে দূরে ছিল অনেক। তো এখন যত আমরা ইটারেশন করতেছি, মানে যত আমরা লুপ ঘুরাচ্ছি সর্ট অফ, আমরা তো কাছাকাছি চলে আসতেছি। এক্স হাইটা আর এক্স লোটা এটা কিন্তু একজন একজনের কাছে চলে আসতেছে। তো আমি যদি এক্স হাই মাইনাস এক্স লো করি, তাহলে তো আমরা যে মাঝখানের পোর্শনটুকু পাচ্ছি, তাই না? মাঝখানের পোর্শনকে দুই ভাগ যদি করে নিই, তাহলে তো এই এই পয়েন্টটা আর কি পাবো। তো আমাদের এই ভ্যালুটা যদি টলারেন্স ভ্যালুর চেয়ে ছোট হয়, এই ভ্যালুটা যদি টলারেন্স ভ্যালুর চেয়ে ছোট হয়, টলারেন্স ভ্যালুটা জিরো সেট করতে পারলে সবচেয়ে ভালো হইতো, কিন্তু জিরো আমরা সেট করব না। জিরো যদি সেট করি তখন ইটারেশন অনেক বেশি বেড়ে যাবে। হ্যাঁ, মানে অনেক অনেক বেশি বার লুপ ঘুরাতে হবে, তো ওটা আমরা চাই না, ওটা আমাদের ইফিসিয়েন্সি কমাই দিবে করে। হ্যাঁ, কাজে আমরা একদম টলারেন্সটা জিরো সেট না করে টলারেন্সটাকে ক্লোজ টু জিরো, ধরেন 10 টু দি পাওয়ার -6, অনেক ছোট একটা ভ্যালু সেট করলাম। তাহলে যে এই যে ডিফারেন্সটা আমরা পেলাম, এটাকে 2 দিয়ে ভাগ করলে তো আমরা এটা পাচ্ছি। এইটা যদি টলারেন্সের চেয়ে ছোট হয়ে যায়, তার মানে ধরেন আরো যদি আমরা ইটারেশন করতে থাকি, আমরা তো আরো কাছে আসতে থাকবো। আরো ইটারেশন করলে ধরেন এক্স লো এক্স আই আরো কাছে চলে আসতে থাকবে। যত ইটারেশন আমরা করব তত কাছাকাছি চলে যেতে থাকবো এই রুটটা। একটা পর্যায়ে যে কত কাছাকাছি যাব, এরকম একটা প্রশ্ন থাকে না, যে আমি রুটের কত কাছাকাছি যেতে চাই, সেটাই হচ্ছে আমার টলারেন্স ভ্যালুটা ডিটারমাইন করবে। আমি টলারেন্সের ভ্যালু যত ছোট দিব, তত আমি রুটের কাছাকাছি যাব। তো যত আপনি রুটের কাছাকাছি যেতে চাইবেন, আপনার ইটারেশন তত বাড়াতে হবে, লুপ ঘুরাতে হবে বেশি। মানে একটা ট্রেড অফ, ঠিক আছে? যে আপনি যত রুটের কাছাকাছি যেতে চাইবেন, আপনাকে লুপ ঘুরাতে হবে বেশি। তো আমরা বেশি লুপ ঘুরাতে চাই না, এই জন্য আমরা টলারেন্সের ভ্যালু মোটামুটি ছোটই সেট করবো, 10⁻⁶। একদম বেশি ছোট সেট করবো না আবার, ঠিক আছে? বা টলারেন্স আপনাদেরকে গিভেন দেওয়া থাকতে পারে কোয়েশ্চেনে। তো যখন আমরা এই যে টলারেন্সের ভ্যালু, মানে এটা খুব কাছাকাছি চলে আসবে, এই ডিফারেন্সটা, এই এক্স হাই আর এক্স লো এর মাঝখানের যে ডিফারেন্সটা টলারেন্স ভ্যালুর চেয়ে যখন ছোট হয়ে যাবে, হ্যাঁ, এক্স হাই আর এক্স লো এর ডিফারেন্সটা যখন টলারেন্স ভ্যালুর চাইতে ছোট হয়ে যাবে, ঠিক আছে? যখন টলারেন্স ভ্যালুর চেয়ে ছোট হয়ে যাবে, এই এই কন্ডিশন চেকটা আমরা করব। এই ডিফারেন্সটা যখন টলারেন্স ভ্যালুর চাইতে ছোট হয়ে যাবে, তখন আমরা লুপ থেকে ব্রেক করে যাব, যে আমরা ইটারেশন করতে চাই না, ঠিক আছে? আমরা সলিউশনে পৌঁছে গেছি, আমরা এটা ধরে নিই, তখন এক্স মিডটাই আমাদের সলিউশন। ওকে, এই এই হচ্ছে গিয়ে কোডের অ্যালগরিদম, সহজভাবে যদি আমি বলতে চাই। সো বটম লাইন ইজ, if I want to say it in 3 lines, then first calculate or 4 lines. First calculate the midpoint and calculate the function value for the midpoint, first step. Then check the function value, the sign of the function value, positive or negative, matches with the function value of low or high. Okay, so for the function value matches with, if the function value matches with f of x high or f of x low, then update that f of that x low or x high with x mid, and do this thing over and over again in a loop. And when the loop will break, if this difference, if f of x high and f of x low is pretty close to each other, how close? If they're close, their their difference is less than the tolerance value. Okay, so if they're pretty close to the they're pretty close to each other, then we can say that our solution is that x mid. Okay, that's the thing, that's the way how we are calculating the solution using the bisection method. Okay, so I guess you are getting an idea how actually we are going to solve any root using bisection method. In the lab sheet you will have the algorithm, so if you just follow the algorithm, hopefully you will be able to write the code, no worries. Okay, let's make a break here.